Okay, these are the AMS sample questions for the exam on Wednesday, October 12th. Our first one, they want us to write this as a mixed number. The first thing that we recognize in middle school is that a fraction is a division problem. So this is the same as 26 divided by 5 or 26 divided by 5. And we're going to divide into this. It goes 5 times. We put that up in our quotient, and that is our whole number. Multiply. 5 times 5 is 25. Subtract a remainder of 1. Since it's a mixed number, it's mixed between a whole number and a fraction. First of all, our remainder goes up as part of our numerator. So we put the 1. So we're going to go ahead and put the 1 up here. And our denominator was 5, and the denominator is going to stay the same. So our answer is 5 1/5. Okay. So fraction is a division problem. Number 2, it says which of these numbers is greater than 1? To be greater than 1, it would be considered an improper fraction. An improper fraction is any number that does not have a smaller numerator or top number. So this one is 7/2, so that's going to be greater than 1 because we would have 1, 2, 3, 4, 5, 6, 7/2. This one's 5/6, so that we'd have one thing cut into 6, and we would have 5 of them, so we don't have a whole one, so it's not greater than 1. And this one here would actually have to draw 71 of them cut into 1, and this is 8/6. This would be 6/6, and then we would need 2 more 6 to get 8/6. So that one's greater than 1. And like I said, in this one, we'd actually have to go ahead and draw 71 of them. So these three are improper, greater than 1. That means that the numerator is larger than the denominator. Number 3, we want to compare these two separate problems as greater than, less than, or equal. So we have, first of all, less than. We can remember this because it looks a little bit like an L, L-E-S-S. So that's less than. This is greater than, the bigger side first, or equal. On this has something cut into sixths, and this has something that's going to be cut into sevenths. So, therefore, if we have 3/6, we're going to have half of it filled in. But 3/7 isn't quite going to be half, because sevenths are smaller pieces, and these are larger pieces. If two people have the same number of pieces, then the person with 3/6 would be more. Another thing we can do with this is we can get a common denominator, which would be 42, and then we can say 7 times 6, so 3 times 6. Whatever we do to one, we do to the other. And then 6 times 7 is 42, so then we would do 3 times 7 to get 21. And we can tell that 21 is greater than 18. Just look at the numerators. On our second one, we have the same situation. We have 6 pieces. So sevenths are bigger than 15ths. This is something cut into 15 pieces. This is only cut into 7 pieces. So if you have 6 out of 7, you have almost the whole thing. So 6 out of 15, that's less than half of the entire thing. So that's going to be less than. So we can always just look if the pieces are different sizes but the numerators are the same. We can just say, well, this one has the same amount of pieces, but the pieces are bigger, so therefore this one's going to be the larger. We could also get a common denominator on these. So to get a common denominator, we would find our prime factorization. This one's just going to be 7 times 1, so this is just 7 because 1's not prime or composite. And this is 3 times 5. And then we multiply the most 3's, the most 5's, and the most 7's. So 3 times 5 is 15 times 7. is going to be 105. So 105 would be our new denominator. And then we'd simply look at 15 times 7 is 105. So 6 times 7 would be 42. And then 7 times 15 would be 105. So we multiply 6 times 15. So we would end up with 90. So therefore, 42 is less than 90. Since we have common denominators, we can just compare the numerators. This is true or false. 4/6 is greater than 5/6. These are the same exact size pieces. There's 6. 1, 2, 3, 4. And then these are 1, 2, 3, 4. So we have 1, 2, 3, 4, 5, and this one's 1, 2, 3, 4. So we can see 4/6 is less. So this is going to be false, because if you have same size pieces and this person has 5 pieces, they are going to have more than the 4. If the denominators are the same, all we have to do is look at the numerators. So that's the reason we get common denominators, and we know that 4 is actually less than 5, so it's not greater. Number 5 asks if this is true. So for this, we're going to have to come up with a like denominator. To do that, we can use prime factorization. So this would be just a 5, that's prime. 8 is 2 times 4, and 4 is not prime, so we take that down to 2 times 2. So we use the most 2's, which are here, and the most 5's. And then I'm going to multiply using the associative. 2 times 5 is 10. 2 times 2 is 4. So 4 times 10 is 40. So I'm going to make two fractions with 40 as a denominator, and then all I have to compare then is the numerators. So over here, I'm going to do 5 times 8 is 40. So 4 times 8 is 32. Then the next one, 8 to get to 40, I would have to do 8 times 5. So I do 7 times 5, and I would get 35. And this, I can see 32 is not greater than 35. So that is going to end up being false. So that is no, it is not true. The next question asks, is this a proper fraction? A proper fraction is any number where the numerator is smaller than the denominator. So this would be the smaller number. Okay? And improper is where you're going to have the numerator the same or larger. So for instance, 8/8 or 12/12 is improper because they're both identical, and 12/10, the 12 is larger, and 7/4, the 7 is larger. But this one is a proper one because the top number, the numerator, is smaller. So for instance, 3/4, numerator is smaller, or 6/9. Okay, so that is a proper fraction. Number 7, they want to know which of these are equal to 1. So we can tell here we have 3 out of the 5 pieces. So therefore, if we had 5 pieces, we just have 3, that's less than 1. This one we have 7/4. There's 4/4, and then 5/4, 6/4, 7/4. So that's greater than 1. And this is cut into 23 pieces, and you have all 23 pieces. So this one right here is equal to 1. Another thing you can remember is that a fraction is a division problem. So 23 divided by 23 equals 1. Next one, they want you to go ahead and give a fraction equivalent to 9/11. So to make any equivalent fraction, you take whatever fraction you have. So we're going to take 9/11, and we're going to multiply it by a number over itself. So they're going to be the identical numerator and denominators. And the reason we do that is because anything over itself equals 1, and anything times 1 is itself, which means it's going to be equivalent. So we can take 9/11ths and multiply it times 2 over 2, and we get 18/22. That would be one possibility. 9/11ths times 3 over 3, we get 27 over 33. We can do 9/11ths times 5 over 5, and we get 45 over 55. So as long as we take this right here and we have a same numerator as a denominator, it's the same as multiplying that by 1. And anything times 1 is itself, so therefore it's equivalent. So of course they could have any number of answers for this problem. Okay. This says to put these in order least to greatest. So the first thing we're going to need to do is come up with a like denominator, and we do that by finding the least common multiple. So therefore this is just 1 times 5, and 5 is prime. This is 1 times 7, and 7 is prime. This is 2 times 5, and 5 is prime. So we take the most 2's, which are right here, and the most, no 3's, so the most 5's. They both have the same amount, so we just put one of them down. And then the most 7's. And then we're going to multiply this to find the least common multiple. So 2 times 5 is 10, times 7 is 70. So I'm going to make 3 fractions with 70 as a denominator. Okay. So I'm going to come here, and I'm going to see that to multiply 5, I would have to multiply that times 14. And so I would have to multiply 2 times 14. So 2 times 14 is 28. So that would be 28 70ths. Then I'm going to go over here to our next one, 7. 7 times 10 equals our 70. So 5 times 10 gives us 50. So we have 50 70ths. And finally, 10 times 7, so whatever we do to one, we do to the others. 7 times 3 is 21. So we can see our smallest one is 21 20ths. So this one is going to be the smallest one right here. So this is smallest. Then we go to 28, that's second. And 50 70ths is the largest. So the correct order for these would be the smallest, 3/10, then 2/5, and finally 5/7. So that's our correct order. Okay, for number 10, all they're simply asking for is in that fraction, what is the numerator? So our numerator is simply our top number, which tells how many pieces, for instance, that we have shaded. And our denominator is the number to make one whole one. So our numerator is going to be 4.